Hello, welcome to my channel, Devops with Prasanna. This is day 21 in Learn AWS in 30-day series. And today we are going to talk about AWS Managed Kubernetes, which is called as EKS. This is going to be an interesting session because we are going to see two demos. The first one is to use multiple node groups with EKS, and each node group is going to have different configurations. And the second demo is going to be using spot instances with Kubernetes. And spot instances helps to reduce the EC2 instance cost significantly. So yeah, I'm very much excited. Let's get started. To start with, we'll see like what is Kubernetes. I'm not going to go very deep into Kubernetes because this session is focused mostly on EKS side. But Kubernetes is a container orchestrator solution. Like for example, in the last session, we discussed about Docker, which is a container system, and Kubernetes helps in managing and orchestrating those containers. And this is a de facto standard nowadays to orchestrate the containers. There are like other solutions as well, for example, Docker Swarm and things like that. But Kubernetes is used in most of the production systems. The reason for that is it's very resilient and cost effective and reliable. I think the reliable is the most important piece here because the resiliency comes from container perspective and cost effective, like it's based on the cloud provider. But reliable because the underlying architecture of Kubernetes is very reliable. That is a key point here. Again, like I'm not going to go deep into it. Like I'll have a different session for covering the Kubernetes alone. But in today's session, we are going to talk about the administrator side of Kubernetes. Like when we say Kubernetes, there are two main components in Kubernetes. One is a control plane, the other one is a data plane. So control plane, as the name implies, it is responsible for doing all the administrative activities. For example, like adding a API layer for accessing the Kubernetes, or ensuring the authentication, authorization, or managing the cluster information in database. So all these things are done by control plane. And the actual work of running the jobs is done by something called as data plane. So it is called as like the worker nodes and things like that. So for example, like in this diagram, this represents the control plane and these represents the data plane. And again in data plane, like it's not going to be like one set of like one group of machines. Like we can have different node groups. And each and every node group can have different configurations. For example, some node group can run big data workload, which means it needs more memory. And some node group can run CPU intensive workloads. And some node group, it can have workloads which are resilient, which means it can run in spot instance. So all these configurations can be added here. And to discuss this in a slightly detailed way, I've given this block diagram. So as we discussed, like there are two components in a Kubernetes, in any Kubernetes cluster. And this control plane, it has different components like API server, etcd database, kube scheduler, and kube controller. So these are some of the things which we discussed. And if you want to understand the components of the control plane in an elaborate way, you can take a look at this article, which I'll be giving in the description. So this will give a very simplified explanation of how the control plane works and what are the different control plane and how one interacts with other. So I'll give this article's description. I'll give the link of this article in the description. Again, like the worker nodes, it contains two components. One is the kubelet and the other one is the kube proxy. This is mainly used to communicate to the control plane and receive whatever the job which control plane assigns to it. Three type of worker nodes which we can create. The first one is self-managed. As the name implies, it is managed by us, like the end users, which means we have to define what is the AMI which we have to use. AMI stands for Amazon Machine Image. And like when to do the patchwork or like when to upgrade the system, all the things has to be done by us. That is a self-managed node group. So, and the next one is the AWS managed node group, which is like AWS will do all the things for us. Like we just have to specify the configuration, like what should be the instance type and in which region we have to create this. And all the other things like what is the AMI to use, when to upgrade the nodes and things like that will be taken care by AWS itself. This is like very simplified version, and the self-managed worker node group like needs some more additional configuration from our side. And the third one is Fargate, which is a serverless mode, which we'll look at it in a detailed way in the next sessions. Ways to create EKS cluster. So there are like three methods, three popular ways to create the EKS cluster. The first one is AWS console or using the CLI. So you can use the AWS CLI, create a Kubernetes cluster. That is like one way, but it is very complicated one. Because when you're going to create a Kubernetes cluster, it's not going to be just like Kubernetes alone. There are like lot of other components involved. For example, security group, IAM role, and how the node group gets assigned with the IAM role and things like that. So it's like a lot more components involved there. And that's why like there is a tool available called eksctl. So this is very similar to kubectl. Kubectl is a client which can interact with a Kubernetes cluster. Similarly, eksctl is used to manage the EKS cluster. And this simplifies the things a lot. We can specify the YAML file as an input to this eksctl. And based on that YAML file, all the configurations for Kubernetes is done. The next method is use Terraform. Terraform is IAC tool, which we already saw in the previous sessions. We can use Terraform to code the EKS cluster. By the way, like what should be the properties of node group and how many node groups we should have, and what is the Kubernetes version which we should use. So all these things can be coded in using a language called HCL in Terraform. And for today's demo, we are going to use eksctl because that is a very simple way to create and manage the Kubernetes cluster. Next one, which before going to demo, I just want to talk about the tools which we are going to use. The first one is kubectl. So like kubectl is a very popular tool, which is a client, command line client used to interact with Kubernetes cluster. And the second one is eksctl, which we saw now, like it's again a command line tool. It's used to create and manage the EKS specifically. Kubectl can work with any Kubernetes cluster. eksctl is very specific to AWS managed Kubernetes, which is EKS. The third tool which we are going to look into is K9s. So K9 is again a command line tool, but it gives some kind of UI functionality, and the interaction is also like much more simpler. So I'll show a demo of K9s also. And there are like some properties associated with the Kubernetes cluster. So for example, when we are going to create a control plane, we have to specify an IAM role for it. So that IAM role ensures like it can talk to the corresponding worker nodes. Worker nodes in the sense like it's going to be EC2 instance. So it will make sure like it has permissions to talk to EC2 instance and form a cluster and things like that. And we are going to specify in which region we want to create the Kubernetes cluster. And the data plane will contain something like security group, which will say like what are the ports to open, what are the inbound traffic to allow, and things like that. And what is the type of instance we are going to create. So this is very specific to a node group. So if we have multiple node groups, we can specify like for each and every node group, the multiple instance types. And the third one is the option for scaling. So again, the node group itself can auto scale, meaning like based on the workloads, it can spin up more number of EC2 instances. So we have to specify properties like what is the min number of instances in that particular node group, what is the maximum number of instances, and what is the desired number of instances. And this desired number of instances is something which will be adjusted by AWS itself based on the workload. I want to create a simple EKS cluster. So we are going to create a very basic cluster, and this is the information there. So we are going to use this YAML file, which is having the cluster config, and the name is basic cluster. It's going to create the Kubernetes cluster in AP South 1. It's going to have one node group, which is called as node group -1. We need 2 instances, and the instance type is 3 small. So this is a basic configuration, which we'll be giving to eksctl to create the Kubernetes cluster. And this is going to be a self-managed node group, which means like we have to specify all the AMI type and things like that. And because it comes with the default, like I'm not giving it here. So I'll save this file. I'll say eksctl create cluster with this config basic hyphen eks cluster.yaml. So this is a very big process. It may take some more time also, but in the meantime, like we'll take a look at a few of the options. Like for example, if you first thing is like you need to have the CLI tool called eksctl in your local, and the documentation for this is eksctl.io. And if you go to installation section, you can find the information to install in Windows, Linux, and then like Mac also. So you can take a look at this and install the CLI. And once this is done, um, then you can create a very simple config file and use that one. And if you see the logs here, it is saying something called as CloudFormation. So again, like CloudFormation is a one more IAC tool. IAC stands for Infrastructure as Code, and this CloudFormation is from the AWS itself, and it's very good in managing the AWS resources. So what the eksctl is doing is it's a wrapper on top of this CloudFormation. So it will create various resources using CloudFormation in the AWS account. So to check this one, we'll go to our AWS console. We'll go to CloudFormation. So you can see there is a CloudFormation stack called as eksctl basic cluster, and the creation is in progress. If you go into this, we know like what are the things it's creating. So I'll go to events. So you know like how many resources this small command is creating. For example, it's creating an ad gateway. It's creating a public subnet route, private subnet route, and then it will create a VPC also for us. We go to VPC. Yeah. So it's saying like its creation is complete. So which means like there is one more VPC which got created. So if I go to VPC, you can see like there is one VPC available, which is this is the name of the VPC. So like as you can see, there are like a lot of resources which are created by eksctl, and it's not just about the Kubernetes; it's also about managing these resources as well. Okay, cool. And the next one which I want to discuss about is walkthrough of other files. Maybe like while it is getting created, I just want to give a walkthrough of other files as well. For example, let's say like we'll go to this multiple node groups. Okay. So we saw like this eksctl is creating a new VPC for us. But let's assume a case where we don't want to create a new VPC. We want to reuse an existing VPC and subnets. In that case, what we can do is we can mention the VPC ID here. We can mention what is the CIDR, what are the subnets available. And if we give all this information, like this will create, this will not create a new VPC. Instead, it will reuse the same VPC. And then it will create multiple node groups for us. I'm saying multiple node groups because you can see there is a first node group and then there is second node group with different configuration. For example, this instance type is T3 small, this is T3 medium, and the desired capacity is 3 and desired capacity is 2. So we can create multiple node groups like this. And I can create my third node group also with, let's say, like yum5.large. Okay. And if you want to know about these properties, like what are the options to give and things like that, the eksctl has very good schema file. If you go to eksctl documentation, if you go to config file schema, you can see different sections here. For example, I was looking at okay. So from here, you can see like what is the ID, what are the other parameters to pass, and this is a description for each and every parameter. To know about the parameters and options to use. The other way is if you go to example configs, this will take you to a GitHub repository where you can see a lot of YAML files, which will give you a very good understanding. For example, If you want to create managed nodes, you can go here and we can check this one. Like we gave the node group name as node groups, but here it's given as managed node groups because it's going to be AWS managed node group. Okay. And then like we can give the desired capacity, min capacity, max capacity, availability zones, and all the options are available here with time tolerations and things like that. So this is good. So like you can check this example to get a reference on each and every parameter. And if you want to know more about the parameters, you can go into the eksctl documentation and check the schema file. The other one which I want to discuss about this EKS is there is a very good best practice guide documentation. So if you can go to AWS github.io, you can see like what are the best practice for EKS from the security standpoint, from the cost optimization standpoint, from cluster upgrades, and all these things are available here. And we used eksctl tool and the YAML file for creating the cluster, but you can use a Terraform also, and there is a blueprint available for that as well. Okay, so this is good. So these are the best practice, and these are the documentation which you can refer to create a EKS cluster. And let's see like what happened here. So this is still in the creation phase. Maybe I'll pause the video and then I'll come back once the cluster got created. Okay, so the Kubernetes cluster got created and we can see that in the logs here. So we created a cluster called basic cluster, and then it's saying something like it could able to update the kube config file. So we are going to discuss this in detail. So, but first things first. So let's see like what are the resources this eksctl had created. So if I say eksctl get clusters, and the region is going to be AP South 1. So if I get this, we can see like there is one cluster which got created in the region AP South 1. Okay. And we want to see what are the node groups it got created. So eksctl get node groups, and then the cluster name is basic cluster in the region AP South 1. Okay, so we can see that in the basic cluster there is a node group named node group -1, and the creation is complete. And then the type of this node group is unmanaged, which means it's not managed by AWS, and it's we have to manage the node group. So that is the idea. Okay, cool. So like this is like some basic commands which I want to show in the eksctl. So it's not only used for creating the resources, but we can get the information about the clusters which got created as well. Okay, the next one which I want to show is how to create a very simple pod in the cluster which we already created. So we are going to create something called as Nginx pod. So for that, I'm going to use Kubernetes documentation, go to the pod section and copy the very basic pod creation template. And then I'll come here. I've already placed this in. I've already copied this here. So this kind is pod and the name is Nginx. It's going to use this particular image. So it's a very basic pod template. And to demonstrate this, I use a tool called K9s. Okay, it's this one. Okay, cool. So it's in a clean state. When I run K9s, this is again a different CLI tool. It's used for having a very interactive way to access a Kubernetes cluster. For example, I can see the list of pods here. If I want to see the list of config maps, I can go to config map and I can see what are the list of config maps. And I can see it in all the namespace or only in the default namespace. I'm going back to the pods view and there are like no pods available now. So I'm going to create a simple pod. Before that, I want to make sure I'm connecting to the proper cluster. So I'll say kubectl config current context. So this is pointing to like a basic cluster with the Prasanna -superstars of the user, which is good. I'll say kubectl apply -f simple pod. So when I do this, you can see like the container got created and it will go to the container creating state. Then the pod will be assigned to that particular worker node, and then it will go to the running state. So there is a life cycle involved there. Cool. But we can see like the Nginx is running. And if we want to see the logs, we can press CL, which is fine. But we can give information like to which node this particular Nginx got assigned. Okay. So this is like a very handy tool. Maybe like in a different session, I'll talk about K9s in detail. Cool. And the next one, which I want to talk about is the AWS console. So till now, like we are connecting to the Kubernetes cluster using CLI commands, but there are like a lot of good information available in the UI also. For example, when I go to this EKS clusters, I can see a basic cluster, which is an active state. If I go into this cluster, you can get information about what are the resources running there. For example, like these are the list of names, a list of pods which are running. Like all these are like system pods. I can go to default namespace. I can see Nginx is running here. Similarly, I can view other things also, like what are the config maps, secrets available for this Kubernetes cluster. And I can go to compute. I can see it at a different level. So what are the nodes available? So because we specified in the configuration that we want to create two TT small instance, it created two instances for us. And there are no node groups, which means there is no AWS managed node group. Like whenever we create a managed node group, that will be coming here. In this case, we created the unmanaged node group. And similarly, we can go for observability, which will use Prometheus to trace the metrics and things like that. But all this, we'll just clean up whatever we created till now. So like we have one running pod, which is called Nginx. I can use KNNS to delete that Nginx pod. So I'm deleting this one. And similarly, like we have one EKS cluster running. So I want to delete the EKS cluster also. EKS CTL, delete cluster, and use this file, basic cluster.yaml. So if I do this, it will start doing the deletion process. Again, like this will use like delete all the nodes and the node groups and then the EKS cluster finally. We came to the end of the session. I hope you liked the session and you got some useful information out of it. If you like the way I teach the things, please let me know in the comments and feel free to subscribe to my channel. Happy learning. Bye-bye.